Hi, everyone. Welcome to another episode of Q&A about history of science and technology. I apologize for being slightly late. I was in another live stream, and I think we're getting warmer in trying to find out ways to see the discreteness of space-time as it is supposed to be in our models of fundamental physics. So that will be an exciting historical thing when we manage to do that. Kind of the big analogy is the discovery of molecules, which had been long hypothesized even from antiquity, and people had argued particularly from the 1600s on, is matter discrete or continuous? And that was really nailed down only at the beginning of the 20th century, and with things like Brownian motion being the thing that clinched it. The thing that is interesting about Brownian motion is, as a phenomenon, it had been noticed 100 years earlier, but its interpretation in terms of molecules was not noticed until the beginning of the 20th century. And so it is our hope that there are things like astrophysical phenomena, perhaps ones associated with dark matter, that have been known for a long time, like a century, and not really explained, but which can, when interpreted in terms of discrete space-time, finally be explained. Anyway, I think we're getting closer on that score, but let me turn now to questions people have here. So Zayden asks, how did scientific disciplines originate and evolve through the centuries? Interesting question. Sort of, where did the different sciences come from, and what was the kind of tree of evolution of the sciences? One question is it a tree? Is it the case that one started off with sort of one proto-science, and that it sort of split up into many pieces and it continues to split up? Or are there mergers where two things that looked like they were different sciences end up actually being the same story? I think there are examples of mergers where people realize that things that they've been studying in one direction, for example, things they might have been studying about biology, are really just the same as things that were being studied about chemistry. But I think probably it is a more dramatic phenomenon that science is sort of split apart. So what was the first science? I suppose it might have actually been in the city of in ancient Babylonia, perhaps, or in general in Babylonian times. And I suppose that the question that was probably the originating one for science is sort of, can you predict what's going to happen? And the question of predicting what's going to happen was really something that astrologers were the people supposed to do that. And the question of how you do that is something where people just had no idea what kind of a thing would lead to a prediction and what kinds of things could be predicted. And so people were looking at doing divination, trying to divine out what would happen by looking at different kinds of things. Like they might look at the notches on the bone of a sheep or something, or the entrails of a goat or some such other thing. And they might say, because the notches on the shoulder blade of a sheep have this form, therefore it will rain tomorrow, or therefore this king will win such and such a battle. Or early on, they would be saying, and there will be an eclipse, for example. And they thought that there was a connection between these sort of just seemingly random terrestrial events. It's kind of like the analog of throwing a die and seeing which way does it come up and saying, okay, it's a 6. So that means it's going to rain tomorrow. People didn't know whether that was the way things worked or not. And really, these three different cases of sort of astronomical phenomena, meteorological phenomena, and human phenomena like winning and losing battles and so on, the question of which of these was more or less predictable and by what means was really quite unknown in antiquity. And I suppose when it came to people sort of being the astrologers, they may have done better at predicting the outcome of battles than they did at predicting the presence of eclipses, because the question of battles is sort of some question of judgment about, well, these guys have a stronger army or whatever else, or have better resolve or whatever it is. And that's something that a human could know. So the thing that kind of launched sort of the science of something like astronomy as opposed to astrology was the realization that there were regularities in the heavens, and that it was possible to kind of fit those regularities to some kind of cyclical phenomenon, et cetera, et cetera, et cetera. And I think that the earliest kind of astronomy was really this fitting of it's going to repeat. There's something periodic here. We can predict what the next element of the period will be. Well, then sort of in another branch there was kind of mathematics that came in through commerce and arithmetic and through land surveying and geometry, that was sort of kind of became fairly clean and abstract and by the time of Euclid, first century BC, I guess. The question of second century BC, of that around that time, so it still was the case that there was only a very sort of empirical notion of astronomy. By the time of people like Ptolemy, there were really geometrical things that you could say about astronomy that were essentially provable from Euclid-style geometry. Like there can only be at most, I don't know what it is, 5 eclipses in a year, just because if you just look at where the Earth and Sun are, and it didn't really matter whether the Sun was going around the Earth or the Earth was going around the Sun, that geometry was really quite the same question at that time. So that in Ptolemy, for example, there's a lot of kind of Euclid-style theorem proving associated with kind of where planets and moons and things like this can be. But that I would say that the question of sort of what became a real science, I think some things were known about optics and geometrical optics. There's, I think, some lost work by Euclid on that subject. And even people say that Euclid was involved in the construction of the Pharos, the lighthouse at Pharos, I think, which was one of the wonders of the ancient world. That was a sort of geometrical optics story. But in any case, so there was a certain amount kind of known about optics and about these things that were very geometrical. About mechanics, well, not so much was known. In fact, it took until the 1600s before people really systematized talking about mechanics. And that was the work of Galileo and then later Newton, of being able to have some definite thing to say, what became Newton's laws of motion and so on, to say things about what was true about mechanics. Now, that was sort of rigid body mechanics. What happens to a projectile that's sort of falling through gravity or something like that? Around a little bit later, but not too much later, came fluid mechanics and things like Bernoulli's principle and things about the compressibility or lack thereof of fluids, those kinds of things. But, so the science of mechanics was something that kind of came into existence in the later part of the 1600s. And that really hadn't, I think, had substantial precursors. People hadn't thought to kind of systematize these things about motion in that kind of way. They had observed the motion in the heavens, which is very regular, but when it came to motion, terrestrial motion, it was all really kind of just, well, things are kind of, there isn't something systematic and sort of scientific to say. So one sees other kinds of things. And I think the real story of the origination of sciences is, when does there start to be something systematic that people recognize to say about some class of phenomena? When can one take that class of phenomena and essentially make a human understandable narrative from those phenomena that really sort of reduce all the details of those phenomena to something where humans can make some reasoning about those kinds of things? So, for example, people had certainly known certain facts about chemistry since antiquity, and people like Agricola in first century AD, maybe a little later than that, were kind of writing down things about the preparation of metals from ores, things like this. These kinds of empirical facts about chemistry were known. And it wasn't, there was then a long period of time when kind of the big, can we do this with chemistry question was, can you turn lead into gold, which was kind of the question of the alchemists. And that was a question that really, in some form or another, pretty much survived up until the 1800s. And at that time, where people started having this sort of systematic thinking about the elements and atoms and different kinds of atoms and periodic tables, things like this, reactions, being able to count the number of atoms involved in reactions by using sort of numerical facts and so on, that was something that happened really quite late. And that became sort of scientific. Chemistry became scientific when it was, I suppose one could say it was a pre-science, when it was really these recipes for heat it to this temperature and throw this thing in and you'll probably get this or that out of it. But there wasn't a theoretical layer to that kind of science until the 1800s. Now, you can look at other kinds of sciences like biology, for example. One could argue that there isn't much of a theoretical layer even today to biology. We have two core theories, the theory of natural selection and the fact of digital, sort of the digital nature of the genome. And I suppose we have sort of a pseudo meta theory that is, things are all chemical and there's lots of things that can be said on the basis of what molecules are present. But those are comparatively weak compared to the theories of physics and so on. And in chemistry, in biology, there were certainly observations of biological and medical phenomena going certainly way back into antiquity. Another thing that sort of became slowly systematic was this question of just, well, there are all these different critters running around the world, all these different species. Can one really identify, can one really define what all these species are? Can one classify them? That was the contribution of Linnaeus, for example, was this kind of thinking about the hierarchy of species, the phyla and taxa and genuses and all this kind of thing that are the tree of life. That was a kind of a systematization which led to a certain scienceization of just, oh, well, there's pandas and there's anteaters and there's this creature and there's that creature. It was a little bit of a systematization. And then with natural selection, there's a sort of, well, there's a vague understanding of how there might be this tree of life, although we still don't really know. I mean, if you say, prove to me theoretically that the Stegosaurus must exist, that's not something we're yet able to do. I have a suspicion that there is actually more to be said about why the Stegosaurus has to exist than one knows already. Just saying, when one is just looking at the evolutionary, the fossil record and just saying there must be between this state of life and that state of life, there must be a thing because evolution is continuous. That's as far as we pretty much got there. But to say what kind of ornate forms might have arisen or might be able to arise, that's something that for which we need a different kind of theory, which I think to some extent we have from studying ruleology and studying the way that simple rules lead to complicated behavior. We start to see what kinds of elaborate behavior are possible from the kind of rules that can exist in biology. But, let's talk about other kinds of science. I mean, geology, for example. Again, these sciences did not arise until quite recently. I mean, people had certainly noticed this kind of rock and that kind of rock, but to make something which is a more systematic story of what's going on was a phenomenon, I think in geology, again, a 1600s type phenomenon. I don't know the history of that as well. But then there are many other kinds of things where, is there a science, is there not a science? Psychology, another example. By the late 1800s, early 1900s, some ideas about psychophysics and sort of being able to do the idea of doing experiments on how people perceive things or how people think about things. The idea of doing those experiments was a slow idea to come in. I mean, people were studying in the 1800s, studying a lot, kind of the perception of color, the perception of sensations of tone and hearing. And that was something, again, that psychophysics came in. The question of can we understand how thoughts work? And can we do that in a systematic way? Well, I think that's still something we don't have a great theory for. I think we're beginning to see, actually, from the successes of artificial neural nets, we're beginning to see some of the things which will be potentially leading to more of a theory of psychology or certain aspects of psychology. I mean, the thing to understand about scientific theories is you have a general area, like how people think, or sort of how different species interact in ecology or something like that. And the thing is, you can have many observations that are the things we traditionally observe, but the question is, then there can be things about which a theory can be made. And the question is, do those things intersect? There could be a fantastic theory about something we don't care about. There could be a theory that says something like, I don't know, some feature of economic systems is this or that thing about the sort of general aggregate probabilities of flows of money in this way and that way. But you say, well, that's very nice, but actually nobody cares about that. That's a feature that in the current way we think about economic systems is something that nobody is paying attention to. And so this question of, is there an intersection between the things about which there can be an abstract theory and the things that we care about observing? That's not obvious. And that's one of the things that sort of really is the moment of scientization and theoretical theory formation, is when those two things intersect in some way. Now, we can ask about all sorts of different areas. I mean, economics I just brought up as a question, is there a science of economics? There's certain known phenomena, there's certain lack of kind of a core foundational set of axioms. I mean, one might imagine in that case that there's sort of axioms about human behavior from which you could build sort of the consequences for economics from those axioms about human behavior, but that hasn't yet really been terribly systematically done. In fact, I don't know of examples. I mean, there are questions in voting theory and things like this where you sort of have an axiomatic belief about how human behavior might work. I mean, in economics, there's sort of the notion of rational agents and things like this. In game theory, there's also some of these kinds of notions that are sort of axiomatic assumptions about human behavior. And then there's a question of sort of, can you build a theoretical tower on top of these? And typically, I would say that my own view is that hasn't been outstandingly successful, partly because sometimes it will depend on the things which are where you make something axiomatic, but humans tend to be rather squiggly and not so black and white in terms of what they do. And it may be that there's a case where it doesn't really matter that the axioms are a little bit off. By the time you built the tower up, that those kinds of little imperfections in the axioms have worked themselves out. They've kind of averaged themselves out, and you have a robust result. Or it could be that those little imperfections in the axioms grow to be more and more important, and then you can say essentially nothing. But it's interesting to see the emergence of new sciences. I mean, in the time since, for example, universities have been well structured or structured and have departments and things like that, there are departments that came into existence. For example, molecular biology was one that famously came into existence. To a large extent, computer science was one that came into existence. Maybe economics to some extent as well. Any field like chemistry that predated the formation of sort of the modern university will have been a pre-existing kind of thing. But the question is, what were the new ones that came into existence? Another one that sort of came into existence was linguistics as something other than a philology, kind of a study of the structure of language. This was kind of a systematic science-like study of language, as opposed to philology, which is more of a kind of a natural history of language, and more of a phenomenology of language, as opposed to a theoretical approach to language. I'm not sure how successful the theoretical approach to language that initiated in the mid-1950s has been, and one saw that in sort of the creation of lots of linguistics departments at, for example, American universities that eventually ended up getting closed. Now, there are also sciences that don't quite make it as sciences, and again, one sees things closing, like geography departments. Those were a thing 100 years ago, and in the US, and not so in other countries, they haven't mostly made it. And that's sort of ironic, given that sort of geographic information systems and so on are now a big thing. And the whole notion geocomputation is now an important thing, and one can imagine much more of a computational geography, so to speak, but the actual sort of subject as it existed didn't quite make it to the science point. Now, I have to say that the general sort of question of how do you make a science? What is a science? This question of taking phenomena in a particular area and formalizing them and having sort of theoretical things to say about them, there have been certain kinds of ways in which to make theories. I've kind of would say I've identified 4 of those that exist over the course of historical time. One is just sort of the what are things made of type of theory. The question of sort of if you're doing biology, oh, you have this type of cell and that type of cell, for example, in biology. What kinds of things are present? That's kind of the antiquity style of description of things. Then by the 1600s, we have kind of the mathematical style of there's a formula for that. Then the 1980s, partly through my own efforts, kind of there's a program for that kind of moment in the development of science theories, this idea that you can formalize things as this kind of computational layer where you're saying the thing behaves according to something which can be defined by rules that correspond to a program. That's kind of that type of layer of scientization of things, which is fairly new. This sort of the computational X trend that of making sciences by using computation as the formalization layer, rather than, for example, making sciences using mathematics as the formalization layer, or the sort of what exists as the formalization layer. Now, you know, there's a new game in town, which is only a couple of years old, which is this kind of multi-computational approach, which maybe I shouldn't talk about too much here, but this is this idea that has arisen from our physics project, in which there isn't just sort of one thread of time, but there are many threads of time, and the observer becomes an essential part of the description of any system, necessary even just to knit together sort of what is happening now, what does it mean by now on these different threads of time. And we're starting to see, my own guess is that there are a whole bunch of fields of science which can be sciencized by using multi-computation and the multi-computational paradigm. I suspect natural selection, I suspect, will go that way. I suspect a bunch of questions about molecular biology and the foundations of life sciences will be essentially, in the end, will be formalized successfully in multi-computational terms in a way that has not been possible through any of the previous paradigms for formalizing things. So that's kind of a new driver for science formation. I mean, I should say, by the way, that the sort of computational X, it's an interesting question whether there are sciences of computational X sciences where the X on its own without the computational layer doesn't really exist. And certainly something like rulology, the study of what simple rules do, almost by definition is a only by computation type of field. But I think there are probably, and I'm probably just failing to think of them, plenty of other examples of that phenomenon. So anyway, a few thoughts about sort of scientific disciplines and their evolution. I would say that the formation of a science seems to me to be more about a class of phenomena where somebody realized, yes, you can make a theory, you can make a science around these, than it is to do with the kind of budding off of one scientific discipline from another. In fact, there are, you know, when you do see a budding off phenomenon, it's very messy usually, because the new science has new types of questions, new paradigm, new methods, and it really doesn't fit. It's really a discontinuity. I mean, one could see that with computer science versus mathematics. You know, it could have been the case that computer science kind of slowly budded off from mathematics, but really didn't, because the methodology is really quite different. It's not about proving theorems and establishing sort of aesthetic mathematical ideas. It's about writing programs for practical purposes. It's about studying computational systems in the abstract, those kinds of things. So, you know, an interesting question is whether, I mean, in other kinds of sciences that have arisen and budded off, you know, material science, for example, material science in a sense had a very long history. I mean, it was a thing that one could say was being done almost in antiquity. But as a kind of identifiable science, I would say that what happened is a collection of phenomena kind of coalesced into being things about which science could be made And that turned into material science, probably in the 1950s, 1960s, and so on. And it wasn't a thing that came out of chemistry, really didn't. It a little bit came out of metallurgy, but metallurgy was something that was at some level more of an engineering field than a scientific field. Crystallography was kind of a slightly exotic scientific field, but those are some of the origins of material science. But again, I think the way that science arose was not by, it's really being studied in chemistry, but then this breaks off. Now, then there are some complicated things that happen. For example, what happened in nanotechnology. Nanotechnology, 1970s, 1980s, it sort of was let's think about making machines out of molecules and so on. It was really a paradigmatically different approach from something like chemistry, which is we've got a bunch of molecules bumping around, and how can we make reactions between them and things like this, a very different kind of thing. But then in the sort of dynamics of the sociology of science, the thing that happened in the late 80s, early 90s was that there was sort of capture of nanotechnology by chemistry. And really the smothering, I would say, of nanotechnology, at least for a while, by no, it really is chemistry. And that happens when there is a sort of a big institutional structure around some field, and it's sort of close enough that it can kind of capture some other field and thereby merge it or smother it. And I think that's sort of a phenomenon there. I mean, I would say that in my own observation of, for example, rheology, the science of simple programs and what they do, that's a new name for it. I mean, in the past, it's been part of what I've called a new kind of science and so on. Although in general, a new kind of science is really about sort of the computational paradigm for science, as opposed to the mathematical one of the past or the structural one of the more distant past and so on. But seeing kind of how does rheology fit in? How does it, what is it? Is it a branch of mathematics? Is it a branch of computer science? Is it what is it? Well, the answer is it's none of those things. And it's none of those things in part because its methods and the things that it finds interesting are different from any of those other fields. It really is a different clump of stuff. And I think that's been the case with most new sciences, is sort of a different set of questions with a different set of methods that discretely come into existence rather than being things that break off from existing fields. I think Galileo had a book called Two New Sciences. I felt very sort of cut rate when in my book, A New Kind of Science, because there's only one of it. But Galileo talked about two new sciences. I've now forgotten what those two new sciences were. Galileo had been interested in science and mechanics. I'm not sure whether that was one of those sciences. I think maybe, again, but what he meant by two new sciences was a place where sort of a new set of phenomena came under the rubric of something that one could discuss in a kind of systematic, reasoned way. Let's see. There's a question from Jamie. It's about present and past. Do I think that Apple's new VR headset will be much different than previous releases of VR headsets? What do past releases of similar products predict? Virtual reality is one of these. Well, first let me say that the Apple Vision Pro headset is an augmented reality device primarily. Well, sort of. It's weird because it is, you can see through it, but you can't see through it with your own eyes. It's kind of a Darth Vader story, I suppose. It's kind of a it has cameras, and it is showing you on high resolution displays what those cameras are seeing in the outside world. It is not the photons coming from the outside world that you're seeing. Those photons are going into cameras. The cameras are turning into electronics. The electronic image is being reformed for you. And so that means that, for example, when somebody's looking at you from the outside, it's a sort of a weird thing because they are seeing a simulated avatar of you based on the cameras inside that are looking at your eyes and figuring out from infrared structured light on your on your eyes, where your eyes are looking and so on. And that's then being synthesized by kind of a image synthesis technology to what you actually are, what you appear like to other people from the outside. And I noticed in Apple's demo that there sort of was a brief section in imagining video conferencing and imagining, because if you are video conferencing with somebody and somebody else is looking at you, well, what they would see if they actually had a camera looking at you is they would see this weird sort of headset on you. And if they see your eyes, they're only seeing the electronic version of your eyes, and they're not seeing the rest of your face. And so there's sort of an effort to say, can you deduce from the local information with your eyes and maybe some other cameras and sensors and so on, sensing kind of muscles in your face, can you deduce enough to be able to recreate with machine learning what you look like in a way that's adequate for video conferencing? And it will be a strange thing, because one will really be looking at avatars of people rather than at the people themselves. And maybe that will progressively get better. Maybe it will be horrifyingly uncanny. I don't really know. Until one's tried it, it's hard to know. But in any case, so sort of the Apple story, recent Apple story, is really fairly different and a rather impressive piece of technology relative to what has existed before. I mean, it's really a pretty serious jump over all the other sort of VR systems that have VR, AR, XR systems that have existed in the past. But what's the history? The history, I guess, goes back into the mid-1980s. The real question for virtual reality is, what does it take to sort of, it's one thing to have a screen in front of you where you're looking at the video image or something of a thing, but it's another to have a head-mounted thing where as you turn your head, you get to see a different image just because you turned your head, and the virtual reality system knows from accelerometers that you turned your head, and therefore it's showing you a different piece of the visual scene. The kind of idea of doing that seems to have arisen, I think, in the mid-1980s, primarily. And one of the big issues there is, okay, you have to have a fast enough computer that it can repaint the scene as you turn your head. And as soon as there's a delay, it's horribly sickening to the user. And I must say, I have always found VR devices that have existed. I haven't actually tried one in probably a year or so. Terrible. But I've always found them that I get terrible motion sickness when I'm using them. And I don't know whether that's because my brain works better or worse than anybody else's, but it is the case that it really matters what the delay is between when you turn your head and when the visual scene changes. Just like, you're riding in a car and when you get motion sickness and so on, it's kind of like, is what you feel in your ears and then in the kind of sensing of orientation and acceleration in your ears, is it consistent with what your eyes are seeing? I noticed that Apple was claiming a 12 millisecond delay time between acceleration of your head and painting of things on the display, and maybe that's short enough. I don't really know what all the other delay times are to be adequate. Now, okay, so what was the history? Well, folks like Jaron Lanier were very much into kind of this virtual reality notion, and there were all kinds of other things, because another issue is when you've got this thing on your head, it's like, how do you define what's going on? And then you have to start talking about gesture recognition and being able to have gloves and things that fit over your fingers and decide where they are and so on. And those were a little bit conflated in those early years. I would say that the first time I probably saw a VR system, the first time I used a VR system was probably 1989 or so. And that had come out of some of that work, very much a Silicon Valley, San Francisco kind of story at the time. Some of it, I think, had come out of NASA Ames research lab in Mountain View and so on. I'm not completely sure of that history. But in any case, there were an early company that really picked up on this was Autodesk. which was founded in, I guess, the mid-1980s by it has an interesting founding history, and there's a lovely book by John Walker, the founder of Autodesk, about the history of Autodesk, that has a very I would say a quite amusing take on kind of the early history of a technology company. It's sort of notable that they did a thing so different from what I did in the formation of my company. The term Autodesk makes products like AutoCAD, and they bought in a zillion other products now that do all sorts of geometry, mechanics, CAD types of things. But originally, they sort of had 5 different products or something that they took to a computer show, and they just saw who cared about these different products. And the one people ended up caring about a lot was this computer design product that was a sort of PC-based computer design product, which had been the case that computer-aided design products had like cost $100,000. Theirs cost a few $100s, and that was what really took off. But the name of their company, Autodesk, was kind of burnt in from the thing that they thought would be the winner, which was some kind of sort of pre-Microsoft Office kind of productivity suite kind of idea, I believe. But in any case, Autodesk was a company that really was the first one to pick up on virtual reality and say, this is going to be a thing that can really be used. What can it be used for? Well, architectural design, which was what AutoCAD had then evolved to being very much, that was a core market for them. This idea of you can kind of go into an architectural space and you can kind of look around and see what it's going to be like. A good idea in principle. It has in the past been pretty difficult to make 3D geometry. You know, when you are drawing architectural plans, it's like you've got the plan, you've got the elevation, and then that's what you've got. And then the people who are constructing the thing get to figure out all the details of how to turn that into reality. Now, you know, I know 24 years ago when I was getting a house built, it was a kind of an interesting challenge to get, can we get some 3D geometry of some of this stuff? And that was kind of right at the edge of where that was reasonably possible to do, but it was a lot of work. I think with modern machine learning methods and kind of the whole LLM story, image synthesis, generative AI, these kinds of things, it is in the process of getting unbelievably much easier to synthesize a coherent 3D scene. And that will really change the story of how easy it is to sort of go into a virtual space in 3D and make virtual reality make sense. But when this was first developing in the late 1980s, none of that was easy. So I think the first VR application I tried was playing kind of virtual tennis in VR. Now, people then soon started talking about the other applications like molecules, for example, being able to visualize your molecules in 3D, things like this. I would say that the look, it's a beating heart in 3D and you can move it around. I have to say that demo has, I saw Apple showed that demo. That demo has existed since the very early days of VR. Now, you know, I have to say it must have been by 1991 or 1992, when I was first thinking about these kind of network models of space-time, the thing that I immediately thought about was, as I try and imagine this network that's evolving and updating, and I'm seeing these places where it's, you know, glowing, you know, red hot and being updated a lot, and other places where it's not, so to speak, not really red hot, but just as a way of visualization. I kind of imagined it will be a giant spider web and I'd be kind of picking my way through the VR microscopic universe. And that was 1991. And we're still not there yet. We might now be just about to, you know, to come to a little bit of closure on a project to do something like that. But we are solidly, you know, 32 years later, it's not there yet. But it's interesting that it was already clear what was conceivably possible back in 1991. It was a very clear kind of what one could imagine doing. You know, you've got this giant 3D network and you're pulling pieces of it like spider webs to kind of see what's behind it and things like this. But and then at that time, there was a brief piece of enthusiasm for 3D displays on computers, particularly using lenticular technology, where you would have these sort of cylindrical lenses built on to there was, oh gosh, which one was it? One of the Japanese early computer companies had not Samsung, not Sony, boy, one of the other ones had a demo sort of lenticular screen type thing, which was a 3D screen. And I remember we had these in like 1992, 1993 at the company. And we even built some demos for it where you could see these molecules sort of coming out at you, coming out of the screen at you in 3D. Not VR, but that was sort of a 3D thing. I mean, it's worth remembering that 3D movies have come and gone many times in sort of whether it was 3D movies based on having, the early thing was red and green, glasses where one eye had red filter, one eye had a green filter. Then in more recent times, it's been polarizing filters where you have vertical and horizontal polarization for the different eyes, and those make different images. But 3D movies seem to have, come and gone multiple times and haven't ever quite caught on. I think it doesn't help that when you're looking through a polarizer, you're necessarily having only 50% of the light coming through. And so you have to have a brighter projector. I'm not sure people always do have a brighter projector. And so it just looks dimmer, and that's a bad deal, and so on. But in terms of VR, the technological thing that has happened is the field of view such that you are not just looking at that display that's occupying the center of your field of view, but you're also seeing to 140, I don't know how many degrees out to the sides, and being able to sense things in your peripheral vision. Our peripheral vision is lower resolution than our central vision, but nevertheless, you can tell there's something there, and you can kind of tell the continuity of objects from the periphery of your vision to the center part of your vision, and that's a really noticeable thing. So I think, for example, this question of can you do the optics to really have something where you have this sort of broad peripheral vision, that's been a thing that, for example, Oculus was something of a breakthrough, I think, in achieving that. There's been gosh, such a long history in VR, and there have been particular industries. For example, military applications are pretty common of those kinds of things for training and so on. When it comes to augmented reality, again, messy history. I mean, the idea of a heads-up display, something very much, fighter pilots and so on, have had heads-up displays forever. I mean, certainly back to the 1950s, I think, where you would have, a half-silvered mirror or some such other thing, and you're projecting up onto that so that you can see it even as you're looking through the windshield, so to speak. I mean, cars of last decade or more have, more than that now, 15 years or so, have been pretty routinely, sort of high-end cars pretty routinely have heads-up displays. That's a kind of at low resolution, that's pretty standard technology. Then there have been, there have been other attempts to do this. I mean, another notable one was Google Glass. I mean, there have been companies like Vuzix that have been around forever and ever, I think independently still, building these kinds of things, I think primarily for military applications. One of the questions is, how good is the resolution? Does the thing actually work? And what are the use cases? And people, like 15 years ago, were talking about, for augmented reality, a common use case is things like construction, maintenance, things like this, where you could say, okay, construction workers might get sort of the plans sort of projected in virtual reality, in augmented reality, so they know when they're putting this piece of wood here or something like this, here's where it's supposed to go because it's indicated in augmented reality. Same kind of thing for surgery, of indicating sort of the correspondence between some MRI image or something and the actuality of what's there, because the MRI image can sort of see what is not seen, when you're just looking at the situation. But I have to say, I remember there was one construction project. Actually, it was for a university construction project where the people were proudly saying, I remember, that we're going to use augmented reality. It's probably 15 years ago now, maybe a decade ago. We're going to use augmented reality to do this construction with all this elaborate concrete whatevers. And I'm like thinking to myself, maybe even probably said, knowing me, well, that means it'll be twice as expensive. In other words, it wasn't really a labor-saving thing, at least at that time. So, there have been many cases where the hardware hasn't quite worked out. The use cases aren't really clear. I just found something I wrote out in 2012, I think, about sort of potential use cases for augmented reality. That was at a time when things like Google Glass were big, and I was like trying to think through what would be potential applications. And I wrote these out. I just tweeted that out actually a couple of days ago, just for fun, because sort of AR is back again. And some of the applications that I have for AR in that list are still very much future, forward looking. And some of them are things where, well, okay, we already know how to do that by other means, like we've got QR codes all over the place, or we've got more accurate GPS and things like this. So I think, the real question is it really going to work? And what are the use cases? I have to say, I probably shouldn't quote who said this to me, but I would say a highly placed person in the VR industry. I was talking to, what was it? Probably is before the pandemic, so about 3 and a bit years ago. And we were talking about kind of the new initiatives, for example, from Facebook and companies like that, with their acquisition of Oculus and so on, of, what are people really going to use this for? And he said, well, the one thing it definitely works for is if you're lying on your back and you're watching television. That's a place where it works. And I did find it interesting that in Apple's announcement, this idea that this thing is it's really just a big screen. And yeah, there are details about you can have screens in different places and so on, but it's really a big screen. And I think that's probably a pretty good application. But to make that application work, you have to have very high resolution, you have to have rapid response, and you have to have a good way of kind of getting the input. I mean, another company that visited, 4 or 5 years ago now, was Magic Leap, which is a company that had several $1 billion of investment in kind of an augmented reality hardware device. I have to say, looking through that device, it's kind of the type of thing where you have to actually visit the company, because nobody can show you a web demo of augmented reality and have it be useful. But you put on the device and it was very nice, bright display, and could do all kinds of things. The problem was, and the secret of augmented reality for a long time is, it's all very well and good to say, well, I'm going to put on the device. The question is, what's really comes with that device? Is it a giant helmet, like a top hat, basically full of electronics? Or, how does it really work? And that has been a challenge for these kinds of things. And I think Apple, I don't think they said what the weight of the thing is. And that clearly is a big issue. I mean, by the time it's a giant kind of thing that's, like a heavy top hat or something, I don't believe I've ever worn a top hat in my life, now that I think about it. So I actually don't really know what they're like to wear. And certainly with this concept of to pull it out of your hat, so to speak. I mean, I know in the past people used to keep papers and things in their hats, and I'm pretty sure that old Abraham Lincoln, when he was about to sort of deliver a speech, would take off his hat and take the papers out of his hat. Maybe that's wrong, but I think that's right. But anyway, so I don't know what it's really like to wear a top hat. It's one of those life experiences I suppose one should have. But in any case, the question is sort of what's the practicality of these things? For me, I had thought back in the early 1990s, I sort of was thinking, well, I'd like to get more exercise. I'd like to walk around, but I'd like to be able to keep working while I'm doing that. And I thought, gosh, I should, even if I'm walking on a treadmill or something, I should be able to use virtual reality to have my display. And then I was thinking of using a chord keyboard, a keyboard where your fingers are always in a position, but it's a question of which fingers you press together. I thought about using that as a way to type things. I had seen a chord keyboard actually once visiting IBM Research. That must have been, oh gosh, early 1980s. I saw that, but chord keyboards never caught on. So, but in any case, I kind of imagined that this was a thing I'd be able to kind of walk around with. I never found that to be practical, and then discovered that actually you could just have a display, and it turns out our sort of motion compensation, us as humans, is good enough that you can be just walking on a treadmill or something and looking at the display, and you can keep locked on the display and you don't really have trouble sort of with not being able to read things. And then I discovered that there was sort of a way of putting up the ergonomics of a keyboard so that you could kind of pivot your hands in the right way and be able to type up to about 2.5 miles an hour for me. But in any case, I think in the theory of it's really just a great big display that happens to be fitted on your head rather than being something you have to carry. I'm sort of looking forward to being able to do my pleasant walks outside with full productivity with this thing on my head, so to speak. But we'll see if that really pans out. But I do think this idea of a really very good display that is virtual like this is potentially very powerful. I mean, there are plenty of things where one can imagine, well, whether it's video conferencing applications, whether it's annotate the visual scene, all these kinds of things. I think those are really unproven. I think the idea that there's kind of, well, okay, so there's a different branch. Gosh, this is a messy history. There's a different branch, which is virtual worlds. And I think that one sees from my friend Philip Rosedale's Second Life, which was kind of an early multiplayer virtual world kind of thing. And then the question is, how important is it that you have kind of a head-mounted display and you have sort of a realistic experience of the virtual reality of those things? How important is that kind of metaverse idea, and versus it's just on a display? It's always kind of the weird thing is that you hear actual voices, even though what you see is kind of low resolution. And one of the things that's very sort of notable about human perception is often the sound matters more than what you see. You would imagine that it's what you see that really matters, but what makes the animated movie really come to life is often, the voice acting, so to speak, more so than the details of how good the animation is and so on. So, the audio channel does matter a lot. And a lot of these kind of virtual world games, yes, the visuals are kind of clunky, but the audio is just straight audio. But I think, what people found in these virtual world games, I mean, there are different kinds of things. There are games, and I'm not a gamer, so I'm not really well educated on this, but there are games where there's really sort of stuff going on produced by the AI of the game, so to speak, and people are on quests and things like that, maybe working together, and there's a virtual world that's built out around those. Then there are things like Second Life, where there's nothing going on except what's created by the people in there. Now, things like Minecraft are sort of intermediate because there's kind of shared goals and so on, but it's I think what's happened is that one of the questions is the kind of non-AI infused kind of virtual world that's just, okay, humans, you're going to fill up this virtual world as you filled up the physical world. I mean, I think Philip Rosedale is fond of pointing out that there's in a sense, there's infinitely more space in the virtual world than there is in the physical world. And you can imagine sort of building a whole, well, first sort of a replication of, I'm reminded of a company I've been involved with called Superworld, which is a company that is sort of selling virtual real estate in a virtual copy of the physical world. That's yet another twist on this whole thing. So it's, what's going to catch on in terms of whether one has sort of a virtual world that is a mapping from the physical world, a purely separate virtual world, Are any of those things relevant, or is it just augmented reality that's just you're living in the world as the world is, and you're getting it annotated in various ways, or you're watching TV or using your computer display in that world? I'm not sure. If I were to guess right now, if the hardware is good, then I think what will pan out is sort of just yet another display device. Just as we had computers, then we had phones, then we had iPads, then we had watches, and so on. This is another form factor of display device, and it may work quite well. And there may be use cases like me doing my walks outside, or even something where, you know, I want to go sort of super productivity and have 10 screens, you know, all arranged around me, you know, sort of too much for just looking around ordinarily. Well, let's see. Memes is commenting, the VR stuff reminds one of video game systems where the hardware might be fantastic, but if the content isn't there, it's probably going to fail. Well, I think that's why it's important that the Apple device might essentially just be a display in the air, because then all the content that exists on displays, just flat two-dimensional displays, is all sort of fair game. And the fact that the thing happens to be binocular and has 3D and so on, well, that's relevant for sort of where you place the displays, but it's not deeply relevant in terms of sort of visualization side of things. I might say that just to make a pitch for our world, you know, Apple has been developing this AR kit that allows you to do sort of various kinds of augmented reality and pseudo virtual reality just on a phone. In the upcoming version of Wolfram Language, we have a AR publish function where you can take sort of the geometry of something that you've created, whether it's a polyhedron or a 3D cellular automaton or some visualization of data or whatever it is in 3D, and you can just say AR publish that, and then you get a QR code, you point your phone at the QR code, and you get something that's sort of a living thing that is augmented reality on the phone. You can sort of place it in your room, or you can make it into the sort of VR version and just sort of manipulate it on your phone. That's kind of a neat thing. Chuck comments, these glasses and headsets need to be comfy and miniaturized to become suitable for everyday use. Yeah, I don't know. I mean, you know, many people have imagined that you really have to wait until it's the glasses form factor. And, you know, whereas the trend for all of the stylish people has been, or many of the stylish people has been, don't wear glasses, wear contact lenses, don't have this this ugly thing in front of your face for the last, I don't know, 20 years or something. Maybe as AR comes to the glasses form factor, it'll be back to wearing glasses again. I mean, this was sort of a pitch for Google Glass, was that, you know, designer glasses and you'll want to wear it type thing. I don't know. I think that's yeah, that's certainly something. I think again, to quote my friend Philip Rosedale of Second Life fame, you know, he's pointed out that a lot of people just don't want to put something on their head where they can't kind of see out, where it's kind of or where when other people look at them, they see this weird thing on their head. How that will play out in the Apple case, I don't know. Lala is asking, what cases are there in education for these new headsets? You know, one of the things that's just the craziest thing about every new kind of technology that comes out is people always say, and it'll be good for education. People said that with movies when they first came out 100 and something years ago. People said that with everything. I mean, people have said that with sort of, you know, people said that with virtual reality back in the day. People said that with these kind of virtual worlds things. It's always, you know, they're this sort of, you know, tour the pyramids with an Egyptologist in a virtual world, so to speak. You know, there are always these educational applications. They often don't pan out. You know, sort of the using computers to magically transform education is really something that has still not yet panned out. I mean, computers are useful for all kinds of purposes. People use computers as tools. You know, we've built between Mathematica and Wolfram Alpha and Wolfram Language and so on, you know, plenty of people using our tools on computers for educational purposes. But the idea that the computer sort of in and of itself is the magic answer for education didn't pan out yet. It may yet. With LLMs, we get to have sort of a personalized tutoring bot that can really personalize its responses and really can learn the kind of the thought patterns of the user and optimize the delivery of educational content. So, maybe that will pan out in that case. But I think it's just such a thing that you see every time as people say it's going to be used for education. I will say another thing about that. When Mathematica first came out 35 years ago in 1988, we're about to have our 35th anniversary later this month. When it first came out, it was widely used in universities, research labs very quickly. And it started to be used in a few high schools. And I was like, wow, this is, at the time it was usable on the early Mac computers and things like this, as well as on higher end workstations that were a bit too expensive for the K through 12 market. But it was usable on Macs, which were available in the K through 12 market and used in that market. And I thought, back in 1988, I thought, oh my gosh, I never expected this. This is really going to take off at the high school level. Well, that was 35 years ago. And I would say that, there have been many successes along the way, but it is certainly not a fully routine thing. I suppose Wolfram Alpha use is pretty routine now at the high school level, sort of through the web. But the idea of making use of these computational tools, it was very confusing because at the very beginning, some number of innovative high schools jumped right on and started using it. And it's like, oh, this is going to go great. But then there's a 30-year period when it really doesn't grow very much. It's the sort of the high-end innovators have adopted it, but there's a vast piece of machinery, so to speak, of other sort of schools with other maybe budget constraints, but I think that's not the single determiner of this, but just sort of mechanisms of how they work that just didn't bring that in for years and years and years. So with these headsets, there certainly will be, as there has been with previous examples of virtual reality, there will be places where it can be used for education. As I mentioned, the military have used VR extensively for education, and I believe AR also, for sort of training for a long time. And obviously when one comes to flight simulators and things like this for airline pilots and so on, that's another place where things like this have been used. In these kind of very high budget training applications, that is a thing that is potentially very usable. In the case of sort of every school kid, it's just the economics are not there. Now, maybe eventually the economics will be there, and it's an interesting question. If the economics were there, if it was, Google had this Google Cardboard thing that was some kind of faux VR type thing, but that was just kind of a toy. But when the economics are really there to make VR something that any school kid can readily have, what will that lead to? I must say maybe my imagination is insufficient, but I'm not thinking of sort of drama there. I think it's similar to 3D printing, where people said, oh, that's going to be great for education. And yes, what we saw again in that case was a bunch of early adopters, a bunch of kind of specific innovators who really brought that into education quickly. And then, it's not the case that that's a routine part of education. And I don't think it's compelling that it could be. I think it's something where, in manufacturing unique devices, medical devices, precision, devices, et cetera, 3D printing is very much a thing. But I think again, I'm maybe my imagination is insufficient, but I'm not kind of seeing it for even if the sort of price point is such that any kid can have it. I think it's more likely to be fun for gaming than it is to be profoundly useful. Now, having said that, our former spin-off company, Touch Press, that made iPad ebooks, and it's kind of was very much sort of faux virtual reality. With the first book was a book about the elements that came out at the same time the iPad came out, that involved these samples of chemical elements that you could spin around I shouldn't say this in the past tense because you can still get that app, that you can sort of spin around on the iPad. That was kind of a sort of a pseudo virtual reality. And that was a very fine thing. In the end, it was not commercially viable, arguably because every different, how many things can you spin around and have fun spinning them around? Okay, there are samples of chemical elements. There are things like, well, we made this deal to go into the Field Museum in Chicago sort of after hours and photograph their gem collection. It's another thing where you can kind of uniquely sort of pick it up and spin it around on the iPad, and you can't do it in person because they won't let you in to, pick up the super valuable diamond or something like this. But the number of things for which sort of spinning is interesting is not huge. There are different kinds of devices on them. Then we had another one, which I thought was a nice app. It was a kind of an X-ray based app where you could spin things around where you could change the opacity and look at them with X-rays, so to speak, and see what was sort of inside things. That was kind of fun. And then I think in the department of crazy corporate stories and the spinning around of things, there was a kind of I would say the thing that perhaps broke the camel's back as far as Touch Press as a company was concerned, perhaps was there was a big effort to get an iPad ebook app out in terms of in time for Halloween. And there was this sort of great idea of, well, there is a collector of skulls who has things that you can put on a turntable and take your hundreds of pictures of it and make something which you can spin around from it, and they're about the right size to put on the turntable and so on. Let's make the Book of Skulls, so to speak. It was called Skulls, and I think it had a physical book that eventually got produced from it that was kind of fun and had a nice text. But in any case, the Book of Skulls and spinning skulls just missed Halloween, which was sort of a disaster. But in any case, that was an example of sort of faux virtual reality for education. It's kind of interesting to look at for a little while, at least. Spare Parts comments, perhaps AI can be used to translate existing educational material into VR suitable content. I bet that's true. I bet that a lot of what is currently 2D imagery, just like movies are routinely using AI-ish methods, are routinely kind of extruded into the third dimension. I'm sure that will be true with some educational content. I don't know how compelling it will be. I'm not sure that it matters much. I mean, I think it's amusing to be able to see that, that picture of a dodo in 3D rather than just in 2D, but I'm not sure how profoundly compelling it will be. All right, I think we should probably wrap up there. Let me just see if there are any more questions related to this particular topic. Looks like there's some other good ones for another time, but I think it's time to wrap up here for now. And thanks for asking. Oh boy, there are a lot of interesting questions here. Okay, we're going to have fun next time. Well, thanks for joining me this time, and bye for now.